This is a video on special segments of triangles. Um, a, a couple of vocabulary things to make sure we're all on the same page here is to make sure that you understand words like midpoint, keeping in mind that the midpoint is a point on a segment equidistant from the endpoints. So a picture for that would be here. M would be the midpoint if those segments were congruent, and that distance from A to M is the same as the distance from B to M. So just to make sure that you're aware of that as we continue to discuss the special segments of a triangle, this is what I need to make sure that you have popping into your head as you keep hearing me talk about this new thing called a median of a triangle. So we're going to start off with a picture. So I've got a triangle here, and this is not anything as far as an isosceles or a right triangle. It could just be any general triangle. A median of a triangle connects the angle of a triangle to the midpoint of the opposite side. So this segment that I just drew in from A to B would be the median or a median of this triangle. Again, it's a segment that connects an angle to the opposite side's midpoint. So since there's three angles in this triangle, I could draw three medians. So A to B, C to D, and even E to F, and those three would be the medians of this triangle AEC. Notice that those three medians intersect at a point inside that triangle. Again, when you see the word median, you're thinking midpoint. So it connects an angle to the opposite side's midpoint. Connects an angle to the opposite side's midpoint. So connects an angle to the midpoint of the opposite side. Okay, so if I want to give you an example of how to work with this, I would first need to solve for x. So if I understand that BM is a median, I would then automatically know that M is the midpoint of AC. So M is the midpoint of AC, which would then tell us that those two segments are congruent and AM is the same as CM. So that means that 3x plus 4 is the same as 5x minus 2. Notice that I'm ignoring x plus 6 because though it's the median itself, that's not where the relationship is. The relationship is knowing that BM being the median made M the midpoint of AC. And if M is the midpoint of AC, AM is equal to CM, which means I could set those two things equal to each other and solve for x. So I'll do that really quickly. Subtract 3x from both sides. And I've got 4 is equal to 2x minus 2. I'll add 2 to both sides. And that'll give me 6 is equal to 2x. Divide by 2. And x is 3. Now, being careful, I'm not done. They want to know the length of AC. Well, AC is this entire side here from A to C. So that means that I'm going to need not only to substitute x in for 3x plus 4, but I'm also going to need to substitute x in for 5x minus 2. And then I'm going to add those two numbers together and get my total. So 9 plus 4 is 13, plus 15 minus 2 is also 13, for a total of 26. All right, next we're going to talk about the altitude of a triangle. So I'm going to talk about perpendicular a lot. So I wanted you to keep in mind that two lines that are perpendicular are two intersecting lines that form a right angle. So when I talk about the altitude of a triangle, I'm talking about a line segment that goes from an angle to the opposite side and is perpendicular to the opposite side. So I start at this angle, and I'll just do one from E, and I want to draw a line segment that's perpendicular, meaning it forms a right angle with the opposite side. So an altitude is a segment that connects an angle to the opposite side and is perpendicular to that side. So in this case, we'll call it M. EM was perpendicular. That's our upside down T is our perpendicular symbol to KG. So that means it forms a right angle there. So I know that this angle here where I've drawn the square, as well as this angle that forms a line with it, are right angles. All right, so let's talk about how we can use knowing the altitude of a triangle. Another thing to keep in mind is that altitude, another word for altitude is the height. So altitude is the height. So when they measure height of anything where it's perpendicular to the ground, so when I talk about an altitude of a triangle, I'm talking about the height of the triangle. All right, so how can we use this? I told you that SM is an altitude. You would know right away to mark that that's a right angle. Okay? So if they then told you that the measure of angle SMP is 10x minus 20, and they wanted you to find x, then you would understand that angle SMP is equal to 90 degrees. So that means that the measure of angle SMP equals 90, which means that 10x minus 20 is 90. So if I added 20 to both sides, 10x would be equal to 110. Divide by 10, and x is 11. Talk about angle bisectors of a triangle. Keep it in mind that an angle bisector is a segment, line, or array that cuts an angle into two congruent angles. So I've got a picture for you to remind you what an angle bisector is. And then I've drawn you our example of this triangle. So notice that line segment NP connects an angle to the opposite side, just like our previous two special segments connecting an angle to the opposite side. But this one cuts that angle at N into two congruent angles. So now I know that angle MNP, that's this angle here, is congruent to angle ONP. That's this angle here. Those are congruent because NP is an angle bisector of that triangle. So again, what's really important for you to see here is that I'm sticking with the theme of connecting an angle to the opposite side, but instead of having some relationship with the opposite side, it's actually cutting the angle itself into two congruent angles. So I can give you an example of how we can put that into motion. And I know that YW is an angle bisector that would tell you right away that this angle is congruent to this angle right here. So if we knew the measure of angle y was 8x, if you divide 8x by 2, you get 4x.
Segment in triangles is a perpendicular bisector. So over here on the right, I've got a definition for you for perpendicular bisector. A perpendicular bisector is a line or a line segment that is perpendicular and bisects a segment. So essentially, it's a perpendicular line or line segment that goes through the midpoint of a side. And what this picture is trying to help you see is that not only do they form right angles for the perpendicular piece, but it cuts it into two congruent segments. So again, it goes through the midpoint. So when I take a look at the triangle, again, staying with the theme of a segment that connects an angle to the opposite side. So it connects an angle to the opposite side's midpoint and forms right angles. Let me say that one more time. Connects an angle to the opposite side's midpoint and forms right angles. So we know that PR is perpendicular to QS. We know that R is the midpoint of QS, and we know that RS is the same as RQ, which is a really important thing to make sure that you've processed all of that. So make sure that you get these definitions down, and then from here, what we're going to do is do an example.
Okay, so what we've got here is an example of a triangle with a perpendicular bisector. AC is the perpendicular bisector of this triangle, ASL. And what I want to do is find the length of AS and find the measure of angle S. Now, what's important for you guys to kind of piece together here is to know that those two things that they want us to figure out actually have nothing to do with the perpendicular bisector. What we are able to do is find what X is and what Y is, and then use those values to then plug in and figure out the length of AS and the measure of angle S. So let's do that. Let's walk through that process. First thing I want to do is go ahead and mark my picture so that I can make sure that we have the given information in place so we can set up our equations correctly. All right, so again, the perpendicular part is that this angle here is the perpendicular bisector. When I say this angle here, I mean angle ACL or angle ACL or angle ACS are right angles. So we can go ahead and mark that those are indeed right angles. So I know that 5y minus 10 is equal to 90 degrees. So that's an equation that I can use to solve for y. And I mean, I could go ahead and take care of that right now. So I'll add 10 to both sides. And 5y is equal to 100. Divide both sides by 5. Y is equal to 20. Now, everywhere I see a y, no matter which angle, no matter which segment that has a y involved, I can substitute 20 into its place. So if this angle S, if the measure of angle S is 2y, that means that it's 2 times 20, which is 40 degrees. So I've taken care of this piece right here. Now my next piece is to find AS. So I'm going to need to figure out X to be able to do that. Well, remember, if AC is the perpendicular bisector of a triangle ASL, then that means that C is the midpoint of that side SL. Because again, a perpendicular bisector connects an angle to the opposite side's midpoint and forms right angles. So I know right now that these two sides are the exact same thing. So I can make some room here and solve for X. All right, so let's do that. I know that SC is the same as LC since C is the midpoint of that side SL. And I could substitute 3x in for SC and x plus 8 in for LC. Now I'll just go ahead and solve for x because I'm going to need that to substitute in to figure out the length of AS. 2x is equal to 8. Divide everything by 2, and x is equal to 4. Now I could take that 4 and substitute in anywhere I see an x. AS is x plus 4, which means 4 plus 4 is 8. So the length of AS, which I've now found, is 8.